Okay, hi guys. So in this lecture we'll be starting off with case 1 of resonance. So let me put down the heading. Case 1. So case 1 is double bond conjugation with the vacant p orbital or carbocation. So this is double bond conjugation with vacant p orbital or carbocation. Okay, so let's say we have this carbocation wherein we have CH2CH and CH2 plus here. So this is sp2 hybridized, this is sp2 hybridized, and this is sp2 hybridized carbon atom. Okay, so how does this conjugation, by the way, what is the meaning of conjugation? Conjugation, the meaning is simply alternate. So the case where double bond is in alternation with the vacant p orbital or carbocation. So if we actually see this structure, this is something like this. We have C here, C, and a p orbital here. There is a bond between these two p orbitals, and we have a vacant p orbital here because it's a positively charged carbocation. Okay, so what happens is this filled p orbital gets shifted to this vacant p orbital, thereby forming a positive charge here. So after this step, what happens is we have a formation of vacant p orbital here, and this p orbital of this carbon atom gets filled with the pi electrons of this p orbital. Okay, thereby forming a double bond between this carbon atom and this carbon atom. Okay, so in short we can write it something like this: CH2 double bond CH2. The pi electrons comes here to form something like CH2 positive charge again here, and something like this. Okay, so we can show this resonance hybrid as this has a partial positive charge and this has a partial positive charge. So we are showing the delta plus half and plus half on the extreme carbon atoms. Okay, so let us look into some more examples of the same. So let's say we have something like this. This was the first example. Now the second example, we have something like here. So what can happen here is the pi electrons or the double bond can come here, forming a deficiency of electrons at this carbon atom. Okay, so the resonance hybrid would look something like this, where we have this cyclohexane ring. Actually I missed to draw a pi bond here. Okay, so the double bond is between these three carbon atoms. It's in conjugation with delta positive shared between these two carbon atoms. Okay, let's look at the third example, wherein we have something like this. So what will happen in this case is, again the shifting of the pi electrons in the p orbital of this carbon atom will take place, resulting in a vacant p orbital here, and again this compound. So what would the resonance hybrid? Resonance hybrid would be something like delta half here and delta half on this carbon. Okay, let's look at the fourth example, where we have something like this. And a positive charge here. So what will happen is, first this can actually come here, so we can have something like this. positive charge on this carbon atom as a result. Now this can actually come here, so again we can have something like positive charge on this carbon atom. Okay, so what would be the resonance hybrid? Resonance hybrid would be something like this, where we have CH2, CH, CH, CH and CH, and partial positive charge between this, partial positive bond between this and this. Okay, so with delta 1/3 on alternate carbon atoms. Okay, I hope you are able to follow this. Okay, let's look at the fifth example, where we have something like this. So what will happen is, this pi bond can go here, creating a positive charge here. This pi bond can then go here, creating a positive charge on this carbon atom. Okay, so what would the resonance hybrid? Resonance hybrid would be nothing but something like this, where we have plus 1/3 here, here and here. Okay, let's now look at the sixth example. We have cyclopropyl methyl, not methyl, carboketane, cyclopropyl carboketane propynyl. Okay, so what will happen is, it can go here, resulting a positive charge here. Again it can come here, resulting in a positive charge here. Again if it comes here, we will have something like the first atom only, the first carboketane only. So the resonance hybrid would be something looking something like this, where we have delta 1/3 here, 1/3 on all the atoms. Okay, so now let's look at seventh example, wherein we have something like this, positive charge here. So what can happen is, this double bond can come here, resulting in something like this, and creation of a positive charge here. Okay, so this will be only resonating structure here. Okay, why this bond is not coming here? It's not conjugate, it's not alternate. Had it been here, then only it can come here, but it is not the case. This pi bond is not in conjugation with the carboketane, hence the resonance hybrid would be something like this. What is mean by resonance hybrid? Resonance hybrid is the cumulative resonance structures, okay, with showing partial positive charge on all the carbon atoms involved in resonance. So this is the concluding hybrid, or showing both the resonance structures in itself. This is the meaning of resonance hybrid. Okay, so now let's look at the last example of this video lecture. We have something like this. CH2 positive here. So now what will happen is, we have something like this. Okay, we first start off with here only. We can have something like positive charge on this carbon atom, double bond here, then again positive bond can shift here, creating a positive bond on the lowermost carbon atom in the ring. Then what can happen is, again this bond is in conjugation, this double bond is in conjugation with the positive charge, so we can have something like this. And what would the resonance hybrid? Resonance hybrid would be simply a summary of all the resonating structures that can happen in the conjugation of pi positive charge with double bond. So we can have something like CH2 with positive charge on here, here and here and here. Okay, so this is the hybrid we can make. Okay, so with this we come to an end of this lecture. In the next lecture we'll be seeing more such examples. Till then, good luck and goodbye.